Welcome to my seminar on effective use of drift joints in exterior CFS walls. I'm pleased to be here with you today, and thank you for joining us. I want to encourage you to submit questions you may have as we go through this presentation, and please feel free to include the slide number, and I will try to get to all of your questions or comments during our three question and answer sessions. So let's get started. Okay, so just sort of an outline. We're going to talk about code required loading and building movements. We're going to talk about it briefly. I will have in about a month, actually just less than a month, a much more in-depth discussion on the code required loading and how building movements are accommodated when it comes to connections back to the building and things like that. That's on August 24th. But we're going to briefly touch on it just because there are things that are relevant to this discussion. We're going to talk about the what and the why of drift joints. Some typical drift joint details that are commonly used in the industry, discontinuities that occur at drift joints that we need to address, and then a little bit about how the facade finishes are affected by the drift joints and how they get accommodated. So let's start with the loading. Of course, we have our typical dead load, live load, wind load, seismic load. A dead load is usually just the self-weight of the wall and everything that's attached to the wall. Sometimes, though, if you don't allow for differential vertical movement, so you don't allow for the live loading, you could, or the building to actually move relative to your exterior wall, you could conceptually be designing your walls as bearing. That's why I put that on there. So similar to live load, almost always our exterior walls are non-load bearing, and so they don't have that. So typically, we're just the self-weight of the wall, the wind load on the wall, and the seismic loads. For wind loading, if you're in the 2015 or 2018 International Building Code, ASC 7 has changed whether you're in chapter, well, it's still chapter 30, but 2015 is ASC 710, 2018 is ASC 716. You want to make sure that you use components and cladding loading when you're designing your non-load bearing exterior wall framing. That's chapter 30. Your corner wind pressures are higher, so sometimes people will design specifically to a corner zone and have different framing requirements or connection requirements at corner zones. Other times the difference isn't enough to make it worth doing a different design there, and they'll just design everything for the corner, the higher load. Your load does decrease with increased tributary area, so you can have cases where your framing is designed for one pressure load, whereas your connectors might be designed for something else. And your suction loads typically govern, which really means that your wind is constant over the height of your building. So those are just some basic things to think about. For seismic load, I just realized I didn't update this slide because 2018 is now on ASC 716. So, but the idea didn't change. There are some changes coming up in the next ASCE, but we got a few years to worry about that. You're going to be using your FCP loads. Something to remember is that your fasteners have to be designed for a higher load because the RCP value and ACP value are different for fasteners versus the actual wall framing. So what that means is that your connectors are designed for a little more than 3 times the load that your wall studs are designed for, and your loads increase up the building height. So again, similar to wind, some people will design for the same load all the way up. Some people will change the loading as they design. Really depends on what economies, what you can get from the being more economical. If it makes a difference in the stud framing, or if you're just using the same stud framing all the way up, it doesn't really matter. So what are the code performance requirements for seismic loading? So the code actually for exterior non-structural wall systems, it doesn't really have a specific requirement. It doesn't say that you may not have damage or anything like that. Basically, the only thing that implies is that the framing can't fall from the building. There can be, however, project-specific performance requirements. So there could be project-specific loading requirements, deflection requirements, weather barrier integrity. So this is kind of where it's really important from the beginning of a project to really understand what the requirements are for your project. And a lot of times it gets interesting because we as structural engineers understand that buildings move and how much they move, whereas most architects, they get it conceptually, but then when you start talking about, okay, what are we actually going to, what performance do you want? And then it gets really squirrely. So one thing, most of the time jobs are in general code minimum. So essentially there it's, you just basically have to make sure that the framing and the finishes stay anchored to the structure. They will, potentially or most probably get damaged. But you can have projects. I had one up in San Francisco where under a specific earthquake, a magnitude 7 event on a certain fault, they actually wanted the weather barrier to remain intact and performing. So that required a lot of special accommodations. The base building, so beyond the loading, we need to account for the fact that the base building moves. So the base building is going to move vertically and the base building is going to move laterally. So let's first talk about vertical.